Good afternoon, good evening, everyone. So in the today's class, we will continue what we have done in the last class on the tip calculator. So in the last class, we started developing a tip calculator app. So in that app, we have started creating the XML layout. So in that layout, in that activity, we have started creating the XML file, and we have started designing the whatever the app interface using the XML file. So initially uh, we have used the um, text views. We have uh, we have we have included it, as I remember, an edit text into the file, and then we have included an editable text view into the UI. So, so I think, sorry. So in the last class, this is what we have been doing, uh, and we have been editing the XML file, which is under the activity underscore main dot XML. In that, we have given basically the these these code snippets to uh, get the views into the place, into our code place, and we have added edit text, then text view, and next we have to add uh, uh, radio views. So in order to do that, we have to add the radio group option. So anyway, like I have regarding that, I have uploaded a second activity file in the LMS. So I believe it is available to you. You can access that, and you can try to follow the instructions from the top. Right? So we will do that activity in this class. So if you have any questions, you can ask. So in the LMS, in the week 8, you can find the day 2 file. In that, you can access the code or the instructions that you have to follow to develop the code. So up to this point, do you get any errors? Right. So at the beginning, you are asked to go through the radio button guide, which is available in the Google. So radio button, how it can be defined in the XML file is given in here. So this is the sample code that you can use to develop a radio button in your, I mean, um radio button group, uh, right? You can. um you can define inside the I mean you have to first define the radio button. um, Sorry, so you have to define the radio group first, and inside the radio group you have to define this radio button, right? So this is a sample example. So I mean this is a sample code. So in here you can see that radio buttons are defined inside the uh, radio group uh, category, and like you need to use this kind of sample code. So so there are different features that you can define inside here. So Android layout width you can define as match parent if you want the width to be same as the width of the parent view. All right. And the layout height you can define as wrap content if the height of the view should be same as the uh, height of the text that you enter into this element. So the orientation of all these radio buttons should be vertical, right? So in general, these are the like uh, definitions for the radio buttons. If you want to make any changes for each button, you can define those changed features or changed qualities in this uh, in these code lines, right? You can define the features for each button separately using these lines: layout width, layout height, and the text that should go inside the button you can define using these lines. So this sample can be used to define radio button. So in that sample, you have to define the layout width and layout height as wrap content, right? So that means that the layout height and layout width will be wrapping the content that is defined inside the radio group. So basically, there can be multiple buttons inside a radio group. Radio buttons, multiple radio buttons inside the radio group, and the total size that the total buttons take inside will be determined by the layout width and height of the radio group. So when you define the features of the radio group in here, basically, if you define the layout width to be wrap content, it means that the layout width will be defined by the contents inside the radio group, right? I don't know whether you can understand. So if you don't understand, you can let me know, right? And after that, you have to add the radio buttons into the inside of this radio group. First, you need to have this, and you need to make sure that you define the ID properly for the radio group, ID properly, and then you need to define the constraints properly. The constraints properly as given in these last lines inside the radio group. Right? So whenever you implement some code, you can run that code. You can check whether that code is working fine or not. Okay, so you have you implemented up to this point where you have the radio group? Right? So in here, the Android orientation means that the views will be placed in a vertical orientation, right? The the views that are implemented will be in vertical orientation. You can run the code and you can see whether there's any error in the code, right? Whenever you add some code, you can maybe run the code and see whether there's some error. There are some errors, you will get them in the terminal where you see the running of the compiling of the code. After you add the radio group, uh, after you add this radio group tag, right? The radio group is like a collection of radio buttons. So inside that, you have to define each radio button separately. Right, so you have to add the radio button separately inside the radio group. You have to set the layout width and layout height of the of each of the radio buttons to wrap content, right? Or else, I mean, here, of course, we are talking about the radio, um, radio, radio buttons. So radio buttons, you can set the layout width and layout height into wrap content. So when you're defining the radio group, you have to maintain an indentation, inside the code, right? So radio button, once you type radio button, you will get by default the layout width and layout height. So since we are going to define them both as wrap content, we can define it as wrap content. So if there's an error coming here, it means that we haven't closed this. So we have to close that tag to remove the errors. Then we have to assign the resource ID into ID, some kind of ID, right? So we can define the ID as ID option. So if you get a red message, then there's some error in here, right? So if there's some red message, means that you have to remove the error. So I mean, in here, okay. Is there any other place where we have defined the same ID? If I have that kind of situation, then it's going to be red. And you have to set the text of the radio button into amazing inside brackets 20%. You can run this and see whether you can see the output. So you will have an output. You can click on this radio button. You can also give some numbers to this edit text, right? When you try to give something else like text, you cannot give it. We have defined, right, in our XML code that the input type for the text view should be decimal numbers. So you should be able to give a decimal number inside here, and then you should be able to click the radio button. So similarly, we have to add two more radio buttons, and you can define different IDs for those two buttons. So we will define these three percentages for the three buttons, and then we will run that and see whether we get an output. If we want to see whether all the constraints are also defined for each of the radio buttons, that is there's not going to be any error. Currently, we have no error. We have all these buttons showing in the vertical manner. So basically, you need to be concerned about the constraints, and you need to be concerned about defining the constraints. And in here, with regard to the radio buttons, we have defined the constraints in common manner, in commonly for all the radio buttons. So the commonly these two constraints are defined for, right? These two constraints are defined in common, generally for all the three buttons. So the top of the buttons margin, or it is constrained by the earlier view that was defined in here. So what I mean is that the place where the first radio button is placed is defined by the place location where the text view is. So with respect to the text view, the location of the amazing radio button has been defined, right? So after that, the other constraints that are defined for the rest of the buttons are defined according to the parent view, and it it the rest of the buttons are also following the same constraints as the previous radio buttons constraints. So if you have any questions or errors, you can let me know. So by now you should be having 3 radio buttons, and that should work. And then now we are at the switch, adding the switch level, and we have to add a switch to the code. So you can try to add the switch into this code as well, right? So so now we have finished defining the radio group. So we can go to the new tag switch. So switch, when we have to define its layout, I mean width and height. We can define it as wrap content. So when we define it like that, means that whatever the text we enter into this switch option will be will be taken as the, I mean, layout width and layout height of the switch component. So add a switch element of the XML after the radio group. As noted above, set the layout width to 0 dp. So the layout width should be 0 dp. So which means that the width of the switch must have a width of 0 dp. So then we have to set the layout height to wrap content. So we will then set the ID to this ID. So we will right. So the switch has are not being placed correctly with respect to the previous component. That is the reason that the switch has a red underline in here. So we have to set the constraints of the switch to remove this error. Right? So we have to define the starting and ending constraints of the switch properly to get the error out. Right? So currently the switch looks like this, and the switches, width of the switch has been set to 0 dp, which means that it is not like expanding over the entire width, width of the screen. It is having 0 dp, or is having the usual default size of the width. So this switch has a default width, and it will be taken as the layout width. Then layout height or the switch height will be depending on the text that we insert on one of the sides of this switch. So after that, we will just go ahead with this. We have to add the text attribute. So we have to add the text into this. So we will add text as a round up tip. So what we want to do with this is that we are trying to round the tip, and we have to we have to add the constraints we have to add. So yes, so we have to add the constraints such that the margin of the switch will be correctly defined with respect to the last radio button or the radio group that we have defined earlier. So we have to define the margin of this switch based on the radio group that we have already defined. So what we want to do here is that we have to add some kind of a constraints, just like we have added before, right? So I have given a sample code for you. So in here, you can see the constraints are defined by these 3 code lines. We can copy paste those. We can add the constraints in here, and then we can try to run the code. And now, since there's no underlining red line in here, since we have defined the constraints for the switch. So in here, you can run the code and you can see how it functions. And you can see you can have this turned on and turned off. Apart from that, you can keep the default options on, right? You can keep the radio. If you take the radio buttons in here, you can keep one of the radio buttons by default switched on. And to do that, you can use a special command in here, which is like Android. Can say checked button. Checked button you can define as the button maybe 18% or 20%, or maybe 18%. 18% is the middle range. So by default, I can see that the middle button is turned on. That one I can do by this code Android checked button, and I set the checked button to this 18%. This is how we can enable the default options. By default, 18% option will be turned on. The similar thing can be done to the switch option as well. So you can define the default option in here. So in here, we can actually define the switch. Actually, switch can only be turned on or turned off, right? So you have to define likewise. how it can be turned on and turned off, right? So uh, that one we will also try to do. So Android checked, you can set it as to true if you want to set the option as true all the time. So when we run it, we can see this is now made to true, and this is by default good. So likewise, we can come up to this point, right? So now we have this calculator which enable us to enter decimal numbers and enable us to click the option that we want. Amazing, good, or sorry, in here it should be uh, what good or okay, I think. So the third one, the text should be okay. So likewise, we can define the three options. Then we can define the switch, which ask us about rounding up the tip. If you want to round up the tip, we have to turn this on. Otherwise, we can turn it off. In most cases, we might need to round up the tip because we don't want to spend the money in like decimals, right? So we want to have a rounded value. So up to this point, have you followed? Do you have any questions? Okay, so after this point, we are going to add a calculate button into this. So we have to add a button, right? So we are going to add a button. So in that, we have to give the layout width and layout height. So we will give the layout width as wrap content and give the height as also wrap content. Um, and then we can give the text that should go as calculate. So with this button, we are going to calculate the tip value. So it should look with the text should be calculate. So next we are trying to give the constraints to this button, right? So the constraint should be uh, defined based on the constraints of based on the location of the previous view, right? The previous view is what we defined as the switch, right? The round up switch. So we have to define the margin of the calculate button based on the switch option. So the layout constraint should be defined at the top of the layout constraint, right? The top of the layout constraint that we are trying to define must be defined with reference to the bottom of the ID round up switch, right? So the round up switch, right? So we can select round up switch in here. So we have said using this command that the constraint of the switch, the constraint of the button that we are trying to design, add in here, is defined. The top of the constraint of this button is defined with reference to the bottom of the switch that we are adding. So after this, I will close this and I will try to see whether, right? I will try to see whether this is working. So still there's some problem. That is why constraints are not defined correctly, and that is why it is having this button underlined. Some problem is there, right? I have defined the margin of this button with respect to the top view switch, but I haven't defined another constraint that says exactly where this button should start and where this button should start, right? I haven't defined like where the button should start. So in earlier cases, we have defined basically 3 lay constraints that gives us the idea about the location of the view, and that gives us the constraints of the view with respect to the any I mean basically at least 2 constraints are defined, but in here only one constraint is defined. So with only one constraint we cannot specify the location of a view entirely. So in order to give the best another constraint, we have to add another constraint, right? So we can add another constraint saying that the uh, right. So we can give another constraint. When you're uh, giving these lines, you have to follow the indentation, and then we have to give the value inside this command. So the button starting point of the button will be based on the start of what what uh, what option is what we are asking here. So we can give, if we want to set the button all over the entire, I mean, if you want to drag the button over the parent screen, that means anyway, I will run this. So if the button is totally spreaded all over the uh, from start to end, it should be parent, and from end to end also it should be parent. So I have only defined the starting point also only in here. In the second constraint, I have only defined the starting point of the constraint, which is starting point of the constraint I have defined as the starting point of the parent view. But ending point of the view I have not defined. So because of that, I have to give the ending point. Okay, I have defined the constraint wrong. Okay, so the button looks like this. So the button constraints had been set as start of the button should be start of the parent view, right? The parent of the button is the view which is totally on top of the calculate button view. So if the parent has a certain margin, that margin is considered as the starting margin of the button, and the ending margin also defined by the parent, that is defined in our system. So so this is how it looks like. However, I think if we try to adjust something, if I want to get the button totally all over the entire width, I need to update the wrap content feature out of here, right? So because I mentioned this should be wrap content, although I mentioned right, there are uh, so this is an important thing, right? um, so in these three lines I define the constraints of the button, and I define the constraint of the button should be uh, such that the left margin of the button should be in the left margin of the screen, and the right margin of the button should be on the right margin of the screen. But it hasn't appeared like that in here. The reason being that I have given the layout width of the button to be wrap content, which means that if I give some kind of text in here, the text will be wrapped by this button, and the button size will be dependent on that text that we include in here. If I, for example, give a lengthy text in here, I think I will be able to get a longer or a more stretched out button. So now I can see the size of the button has increased. It's mainly because I have given a lengthy text in here. But in case I don't want to give a lengthy text in the button, but I want to increase the size of the button in a manner such that I want to spread the button all over the entire width. That is the case, I keep it as DP, 0 DP initially, 0 DP initially. So 0 DP means, like, DP is the dimension, the measuring unit. So density of pixels, right? Density of pixels is given by this DP value. So 0 DP means, like, we start with the layout with having 0 value. It is the default value. But in the end, we define that the constraint should be like that, such that the button boundary is touching the end of the margin of the screen. And therefore, we will run this and see whether there's some change. Should change, hopefully. So now I believe that we can see the calculate button is stretching from the starting point of the screen, right? The screen, which is the parent view, right? Parent view is the screen, and the parent view starting point is taken as the starting point of the button. Parent view ending point is taken as the ending point of the button, right? So those are the two things that we are defining in these two lines. The parent's starting point is taken as the starting point of the button. So when we are defining these constraint code lines, we have to remember one thing, that initially we define the starting point of the button, that is that is object that we are considering. And next, the second start off defines the object to which we are referencing to. So this is the reference object's starting point. Anyway, up to this point, I think we can do the layout, and we can do the design up to that point, right? And then we can also add some kind of text. So we can add a text at the end as well. At the after this calculate button, we can add some text as well. So if we press this calculate button, some kind of a amount must be shown in here, right? Some kind of amount must be shown in here, and that will be shown, that text will be shown inside a certain text view. So we need to add a text view that can show that, right? So we need to add a text view that can show that. So text view, the text view should have a value for the layout width and layout height. For the layout width, we will give as wrap content, right? Which means that whatever the text we provide inside this text view will define the layout width and the layout height of that view. And then we will give the tags like this. We need to give the ID for this object. So we will give a certain ID. ID will be depending on the right, will be depending on the text view, whatever the type that we are trying to give. So we will give a certain ID, and the ID, so we have to give some text also, but the default text that will go in here. So we will give the default text, and still we have some error in here. So we have to remove that error by defining the constraints of this text view. So the constraints must be defined with respect to the previous view that we have defined. So the previous view that we defined is this button, that we have defined. So the button also should have some ID. Tip result or tip amount. So we have to define the constraints. So constraints must be defined with respect to the button that we defined earlier. So we have to define the constraints. So the top of the constraint must be defined. So the top uh, top margin of the text view will be defined with respect to the bottom of the button that we define. So button, calculate button, right? Calculate button. With respect to that, we can define the top margin of the text view. Apart from that, we also have to define the starting point and ending point of the text view. If you want to give the text view in one corner of the screen, we can define accordingly. We can define the constraints accordingly. If you want to give the text view in one corner of the screen, we can give the uh, constraint as the end of the text view must be the end of the parent. So which means that the text view, end of the text view will be equal to the end of the parent view. So we will run this and we will see how the output looks like. So see that we have placed the tip amount text view exactly in the end of the screen, right? That is possible with the use of this layout constraint command, where we define the constraint to be end of the to be to be equal to the end of the parent. So the end margin of the text view must be equal to the end of the parent margin. Right? So up to that point, I think you must have completed. Do you have any questions up to that point? If you have any questions, can you ask? Okay. If you don't have any questions, you can also, I mean, try to enter your attendance details through this OTP. Okay. I would like to discuss with you some XML, important XML codes, and that will be useful for our that were useful for our XML design as of now. Uh, so so let's take a look at this slide. So let's take a look at this code, XML code, where you define a text view, and in there you first you define the layout width. Layout width is defined as wrap content. Wrap content is meaning that the width of this layout will be defined by uh, the the text that we put inside, right? If we increase the text size to a certain value, the layout width also will change based on that the width of the text that we enter. If we increase the font size, the layout height will increase. The layout height, if it is also defined as a wrap content, that means that the layout height will depend on the size of the font inside this text view. So all type of views that we define in this Android Studio, all these text views are actually having a boundary which is rectangular. A rectangular area bounds the text view, button view, image view, likewise all the types of different views. So they have a boundary which is rectangular, and that boundary is what we are trying to define. I mean, we are trying to define the dimensions of the boundary. So the boundary width is given by the layout width, boundary height is given by the layout height. Whatever the text that should go inside that is defined by the Android text, right? Android text, and it can be any type of text that you enter here, and you can define the text that goes into it. So apart from that, what does it mean to wrap content? So I mentioned to you that wrap content means the content inside the view will decide the width or the height of the layout. So the layout is basically the rectangular boundary. So the match parent means that the layout of the bound or the layout of the view or the boundary of the view will be defined by the parent on top of which the view is placed. So if we have match parent, that means that uh, we have to like match the width with the parent's width. Fixed value means that we can give a layout width based on the width that we want to define in terms of density pixels. DP means density pixels, and if we want, we can give the layout width uh, as any value that we want. It can be any fixed value that we want. It can be 50, 58, something like 48, some kind of constant value it can be, right? And then when we discussed about text views, right? So this is one of the types of uh, ways that we can place the text view. So text view can be placed inside the screen, and there's only one text view or one view, one type of element inside a certain layout. We call that frame layout. And such kind of frame layout can be defined like this, and it looks like this. There's another type of layout which is linear layout, which uh, right, there's another type of layout called the linear layout. That linear layout will have the views placed in a linear manner, in either in the horizontal or vertical manner. right? We can place the views in either this vertical manner or horizontal manner. So in here, the views are placed in the vertical manner. So in the linear layout, we will have all the views placed in a certain order, like horizontal or vertical or horizontal. In the constraint layout view, we will have the text views and buttons in any location and in any order that they want. But the only thing is that we have to define the constraints properly for each of the views, right? So the constraint layout is something that is widely used, and it allows us to put the views in separate, in specific unique locations that we want, and place them in some unique locations that we want. And um, uh, we can do that by defining the constraints from right, constraints on each of the views, and the constraints will be defined based on the parent layout, right, or the other other views that are available in the layout. So so these three types of layouts are uh, uh, types of view groups that can be defined. So these view groups is a certain uh, uh, a certain group of views, right? View group is a collection of views that determines how the views are displayed uh, in the uh, interface. So right, so the group of views are right. So the views are, there are group of views inside a certain main uh, main parent view or main parent layout. So in here, view group is the parent, and the views inside them are called as children. So these single things, text view button, those are called children. And the main screen on top of which these views are placed are known as the parent, right? So the screen that is behind the view or on top of the view is known as the parent. Inside the parent, we have child, right? So in the frame layout, we have only one child, right? Most of the time, it's like that where we have only one view inside the screen. So inside the screen, we have only one view. In the linear layout case, we have multiple views, and that multiple views can be placed in a vertical manner or a horizontal manner. So both options are available in the linear layout. In the constraint layout, we can define the views to be placed in. We can place the views in any manner that we want. The constraints will be defined um, with respect to the parent or to the other views that are available in the screen, right? So I think there's one request to share the OTP again. I think so. I think I will share the attendance screen again. Okay. Okay. Can you see the screen? I hope you can see the screen. So I hope you can mark your attendance. Okay. So with the frame layout that I just mentioned before, you have only one view inside the frame layout. So inside the parent view, right? Inside the parent, you have only one view. So uh, basically, a frame layout generally holds one single child view. So the child view could be text view or button view, image view. Likewise, there could be different types of views. So depending on the type of view, you can mention that inside the frame layout. So the frame layout, uh, uh, right? The frame layout will be defined like this. So the text view will have, right? Text view will have text view, and its layout, width and heights will be defined. Uh, will be defined in the way we want, and we can define it as either match parent if we want to match the width of the text view uh, um into the width of the parent, and likewise we can actually define our text view according to our specifications. The width and the height we can define using layout width and layout height. There are three main options basically: wrap content, match parent, and we can give fixed values for the width and height. For the linear layout example, we have the linear layout. We can have either in horizontal format or in the vertical format. So in this view, you can see that it is in the uh, vertical format, right? The orientation has been set to vertical. So the views that we place will be in a vertical format. And we can have text views, button views, image views, multiple different types of views we can place inside this linear layout. The linear layout defines the layout, the entire layout for all the different items that we place inside the layout. So right, the orientation of all the views are defined in general using Android orientation line, right? So that means that all the, I mean, orientation of the text views and button views are defined as vertical orientation, right? So orientation of the views are defined using the orientation command that we give on top of all the views that we define. So another thing that we can see is that uh, inside a certain linear layout, we can define uh, text views, image views, but also we can define another linear layout inside a linear layout. So this is one example of that. And we can define images, text views, and then another linear layout we can define. And inside that linear layout, we can define two buttons, other text views, though those things we can define. So this is like a way that we can define views in interfaces. So basically, once we have defined the layouts, the layout will be defined under the layout files. Relate all the related resources related to the layout will be stored inside layout. So inside the layout files, you can see basically the XML code, right? So in the Android Studio, if you go to layout files, you will be able to see the XML file that we use to design the app interface. Images and audio files, user interface strings, app icons. They can also be found in the resource files that are available in the Android Studio, interface, right? You can find all these files inside the Android Studio interface. So basically, that's that would be regarding the resources. And so if you want to find the resources in your app, you can find those resources under resource folder in the directory. Under the resource folder in the directory, you can find the resources related to your app. And under layout, you can see the XML file that you create to develop the interface design. Then other resources also can be found inside this resource folder. So under drawable folder, you can find resources such as images that can be included into this app. Apart from that, other resources also can be found in map and values, and so on. So you can include the resources inside these folders. So that is basically regarding the resources. So so far what we have discussed was one of the resources, which is the layout of the interface, app interface. So during this class, we have discussed about the app interface and how the layout is defined in the app interface. So once we define the layout, that layout file will be stored in the resource directory. So the resource directory is found in the place that I mentioned to you under the resource folder and under the layout files. So every resource that we have in our layout file has a certain ID to it. We define always certain ID to each of the resource, right? So whenever we write the code, we have to define the ID to that element. So using that ID, we can always and easily we can access uh, the certain element in the interface. So when we are writing the code, we have to use these methods to access the resources in the interface design. We have resource file called capital R. We can go to capital R dot some kind of resource file name under which it's available, and then we can access the resource. If our resource is available in the drawable folder, and then its name is IC launcher, we can give this command to access that IC launcher file or whatever the XML file if needed. So that is one way of accessing the resources that are available in the layout files using the Kotlin or the logic files. So, from the logic files, you can directly address the resources available. Right? So each individual text views will have a certain ID. That ID will be defined by ourselves. We can give a unique ID to each of the individual views. Right? So we can give ID and slash, whatever the ID name you can give. And so these things will automatically pop up once you write the code in the Android Studio. So, right? So you can refer certain specific ID by referring to its ID name, right? So in here, the ID has been defined as hello text view. So if we want to call this object text view, we have to call that text view using r.id.hello text view. So that is a way of calling the resource that we want. Right? Okay, I hope you were following up to this point. So basically in this, up to this point, we have discussed about the layouts, how we can define the layouts, how we can define the um, layout in a certain manner, such that the views that we place inside the application interface will be placed in a certain order, right? We have to keep them in a certain order. The buttons and other views like text views and image views, we have to keep them in a certain order. That order can be defined using some, constraint layouts, frame layouts, linear layouts. So we can use the layouts that are available in the Android Studio to define the location of the views and to place them in a certain order. After you place them in a certain order, and when you're satisfied with the design, then you have to go and implement the algorithm on top of the interface. So in order to do the algorithm, in order to implement the algorithm, you have to first call all the views that you have defined in the layout files. So in order to access the whatever the layout files, you have to give the command r.layout.activity underscore main. And this command will enable us to access any object that we have defined inside the resource file. The capital R in here correspond to the resource files, right? If you are not understanding, please let me know. And whenever there's whenever we run the application, the first thing that will happen is that the code will be compiled and this on create function will be activated. And whatever the algorithm that we have defined inside the on create function will be run. The activity will be shut down. After you run the code, entirely the code, the activity will be over. So basically up to on create is a function which we run once we call the activity or once we compile the app. Okay, so do you have questions up to this point? Right, so the whatever the set content view function in here, right, uh, actually enable us to access all the views that we have defined inside the layout file, and allows us to obtain any object that is inside this file, right? Because of that, this set content view is known as the activity. I mean, it's known as a inflator or layout inflator, right? So the activity, the method called set content view, right? The set content view is known as the set content view is known as the layout inflator. which can inflate the layout files up into this format where it shows that the views are ordered in this manner, and also gives each view as objects, right? So uh, so that is some function in uh, the set content view method, right? So we can we can go to different uh, commands that are available. So whenever we want to access any kind of a view, we can use the find view by ID command. Using that command, we can access the different views with a certain ID. So if we define a certain ID using this ID value like text view, if we give the ID name as text view, we can access that ID using id.r.id.text view. If we define the text view name as like hello or something, we have to write r.id.hello, right? The ID name should come in here instead of text view, right? And then if we want to change the text value, right, that is there included in this text view, we can do that by giving this command which says that the result view right, result view variable and its text value should be changed to goodbye. So in here, in this first or second line, it says we have defined that the result text view is a variable that corresponds to the text view that is available as the view in the resource file under the name text view, right? So whatever the text view object we have defined as a variable in here, that variable name is result text view. The result text view and its text can be adapted and it can be made equal to another text value that we want. If we want to update, we can do that. So up to this point, if you have any questions, you can ask. All right. So I think you don't have any questions. So I will share us, right? So I will give a quiz, right? So as usual, I will give a quiz. So those of you who are available here, you can join the quiz. Right? So you can join the quiz if you are available. There are 5 questions. So please join if you are there. After this quiz, I hope to end the lesson. Okay, there's one student. Okay, good. So put your registration number. Shall I start? Right. I think I I will start. Okay. Which view attribute do you use to set the width of a view so that it adjusts to fit the content? Right. So the correct answer is the one that most of you have selected, which is that the layout width should be defined as the wrap content. If you want to define the layout width according to the contents that we put inside the view. So if you have any questions and any place you want to clarify, you can discuss. Okay. Which method on an activity inflates the app's layout and makes its views available as objects? Okay, so okay, so I have discussed that in the activity. In the activity, you have a method called set content view, right? Set content view is the method that allows you to access the resources in uh, the layout files, right? In the app's layout files. So you can access the resources using set content view method, right? I hope it is something that you can remember. So if you go to if you use this set content view method, you can access the resources inside the layout files. The layout file is defined in some other location, right? But once you call this method set content view, you can access that XML file and also access the views that are inside the XML file. And the views will be accessed as objects. Other methods in here are for other purposes. So they are not actually accessing the layout files views separately. So set content view method is the most correct answer. Okay, so scores are like that. Which of the following is a view group? So there's edit text, text view, linear layout, button. Okay. So many of you have given that text view is the view group, but so text view is just one view, one view. View group is a collection of views. So in the linear layout, we have collection of views. We can have multiple views, text views, button views, any type of views. We can have multiple of them as a collection, and that collection is defined as the linear layout. There are other types of layouts like frame layout, constraint layout. So one of the linear layout, of course, has collection of views inside it. So it has a certain it, I mean collection of views, and therefore it is a view group of views. Other all these types are single views, right? Edit text, text view, button. Those are actually single views. Okay. So the scores are like this. Styles are resources defined in styles.xml. Using styles, you can define colors, fonts, text size in a view. Right? So the correct answer is true, right? So by changing the style, I mean by changing the XML file, you can define the colors, font sizes, font types, and any other related features to the appearance of the interface and the features in the interface. You can change using the XML file. XML file is used to define the style of the interface design, right? So you can change the design basically using the XML file. Okay, so the scores are like that. The last question. A view can contain any number of view or view group as its children, true or false? Okay, a certain single view cannot contain number of views under its its view, right? So a single view cannot contain couple of views, but a view group can have multiple views as its children. So a view group is the parent who has multiple children, but a view who is a child cannot have uh, several views underneath it, right? So a view cannot have multiple views underneath it, but view group can have multiple views. So these are the results of the quiz, and I will upload the results in the LMS. So thank you for joining the quiz. I will upload the results and in the LMS. So with that, I would like to end today's class. So if you have any questions, you can ask. Otherwise, you are free to leave if you have other work. Thank you so much.